Okay, so picture this. It's a blazing hot summer day, the sun is just beating down, and you reach into your closet for a dark black t-shirt. Honestly, that just feels like a terrible idea, right? Or think about this. When you light a campfire, or maybe just an incense to get home, why does the smoke always seem to travel straight up? Well, these might seem like totally random everyday mysteries, but they're actually governed by the exact same scientific principles. So let's dive into this, because today we're going to unlock the secrets of how heat moves around our planet and solve these mysteries once and for all. Welcome to This Explainer. If you're a student gearing up for your science exams, well, you are in exactly the right place. Consider this your ultimate cheat sheet. We're going to take the chapter on heat transfer in nature and break the whole thing down into a clear, easy-to-understand masterclass. By the end of this, you are going to feel completely empowered and ready to tackle absolutely any question they throw at you on this topic. Let's get into it. All right, here's our roadmap to exam success. 1. Conduction. 2. Convection. 3. Radiation. 4. The water cycle. And 5. We'll wrap up with some crucial exam tips. Starting off with number 1, conduction. This is all about how heat moves through solids. So what is conduction really? Basically, it's the process of heat transfer from the hotter part of an object to the colder part. But, and this is an absolutely crucial point for your exams, the particles themselves don't actually move from their positions. Let's make this super simple. Imagine you're sitting in a row of desks at school, and you need to pass a heavy textbook to the person at the very end of the row. You hand it to your neighbor, they hand it to the next person, and so on. The book, which is our heat in this analogy, travels all the way down the line. But you and your classmates, the particles, you stay seated exactly where you are. Now, materials that let this heat pass through them easily, we call those good conductors. Metals, like aluminum and iron, are fantastic conductors, which is exactly why your kitchen cooking pans are made out of metal. But on the flip side, materials that block heat are called insulators. Things like wood, glass, and clay are just really poor conductors. And actually, that's why we drink really hot tea out of clay or porcelain cups. They insulate the heat so you don't burn your hands. It's also why wooden houses are so effective at blocking that freezing winter cold from getting inside. Moving right along to number 2, convection. This one applies mostly to liquids and gases. Convection is heat transfer by the actual movement of particles and liquids and gases. So unlike conduction, where everyone stayed in their seats, in convection, the particles physically get up and move around. Here's how it works. When air or water gets heated, it expands, it takes up more space, and crucially, it becomes lighter. And because it's lighter, it rises. This beautifully answers one of our hook questions from earlier. Why does smoke go up? Well, smoke is just a mixture of hot gases. Since it's warmer and lighter than the cooler air surrounding it, convection literally forces it to rise straight up into the air. Okay, listen up, because this is a super common question you'll see on your exams. Sea breeze versus land breeze. This entire coastal wind system is completely driven by convection, and it's because land heats up and cools down way faster than water does. So during the daytime, the land gets really hot, warming the air right above it. That hot air rises, and the cooler, heavier air from the sea rushes in to replace it. That is a sea breeze. But at night, the exact opposite happens. The land cools down super fast, but the sea stays nice and warm. So the warm air over the sea rises, and the cool air from the land blows out toward the ocean. And yep, you guessed it, that's a land breeze. All right, on to number 3, radiation. Heat transfer where no medium is needed. Radiation is the transfer of heat that literally does not require any material medium to travel. It doesn't need solid particles, it doesn't need a liquid, it doesn't even need air. It can travel through the absolute complete vacuum of empty space. I mean, this is exactly how the immense heat of the sun reaches the Earth across millions of miles of nothingness. And this brings us right back to our other hook question. Why do we wear white clothes in summer? Because white and light-colored clothing actually reflects a ton of the sun's radiated heat away from your body, keeping you nice and cool. Dark surfaces, though, they absorb that radiation, which is exactly why a black t-shirt in summer is going to make you feel incredibly hot. Now, what's really cool is that conduction, convection, and radiation can all happen at the exact same time. Just picture a simple kitchen pan boiling on a stove. First, the heat travels from the hot flame directly into the solid metal of the pan. That's conduction. Next, the water inside the pan heats up at the bottom, becomes lighter, and rises to the top, creating this rolling boil. That is convection. And finally, if you hover your hands near the side of the hot stove, you're going to feel the warmth hitting your skin through the air. That is radiation. 3 concepts all working together in one perfectly simple example. Let's shift gears a bit to Section 4, the water cycle. All these heat transfer concepts, especially radiation from the sun, actually power the Earth's ultimate water system. The water cycle is this continuous loop, and it happens in 3 main steps. Step 1, evaporation. The sun's radiated heat warms up oceans and lakes, turning liquid water into a gas called water vapor, which rises into the sky. Step 2, condensation. As that vapor gets higher up where it's colder, it cools down and clumps together to form clouds. And step 3, precipitation. When those clouds just get too heavy, all that water falls right back down to Earth as rain, snow, or hail. But hey, what happens when that rain actually hits the ground? It doesn't just all flow away into rivers. A huge amount of it goes through a process called infiltration. Now, this is a great vocabulary word for your exams. Infiltration is quite simply the process of surface rainwater seeping deep down through the soil and through cracks in the rocks beneath the Earth's surface. And where does all that seeping water eventually end up? Well, it collects in something called an aquifer. Mark this one down, it is a highly probable exam term. An aquifer is basically this underground layer of sediments and rocks that acts like a giant natural sponge. It stores all this groundwater right in its tiny pore spaces. So when people dig a water well to get fresh drinking water, they are literally drilling straight down into an aquifer. All right, we made it to Section 5, exam tips. Time for a rapid-fire review. Let's mentally check these off your study list to make sure we've got it all locked in. Number 1, conduction. Remember, the particles stay put, passing heat down the line like a book, mostly in solids. Number 2, convection. The particles actually physically move here, rising when they get hot, and this happens in liquids and gases. Number 3, radiation. No medium needed at all. It travels through empty space straight from the sun. Number 4, conductors, like metal, allow heat to pass easily, while insulators, like wood and air, block it. And finally, the water cycle is that continuous loop of evaporation up, condensation in the clouds, and precipitation down. Guys, you are now fully equipped to revise this chapter quickly and totally crush your exam. But just to test your active recall, I'm leaving you with one final thought-provoking challenge. If you leave a metal spoon and a wooden spoon outside in the hot sun, which one heats up faster? And exactly which heat transfer concepts from today's explainer prove why? Try to think about radiation, conductors, and insulators to build your perfect answer. Thank you so much for joining me today. Keep revising, keep practicing, and you're going to do great.